A spacecraft from another solar system invades the night sky. But this is not our sky. We are the invaders. The search for alien life has begun. Within a few decades, unmanned probes equipped with artificial intelligence may find life on planets beyond our solar system. Scientific experts have researched and verified the simulated journey upon which we now embark. The expedition takes us to an imaginary planet called Darwin 4. Gaining an understanding of the life supported here tests the greatest minds of our generation and requires the best of modern technology. Because here on Darwin, life is full of surprises.
We think that other worlds, perhaps other Earths, if you will, exist. We know of hundreds of other planetary systems right now, and that may be the tip of the iceberg.
The life we have on Earth must have spontaneously generated itself. It must therefore be possible for life to be generated spontaneously elsewhere in the universe.
It isn't conceivable, really, that there would not be life. Is it intelligent? I don't know. That's a whole nother issue.
On this imaginary expedition, the Von Braun, an interstellar craft, leaves Earth's orbit for a planet 6.5 light-years away. Are we ready to confront the technical challenges of a mission that will take decades to complete? To find out, a team of top scientists, engineers and artists have created an imaginary mission to Darwin 4, fourth planet in a system called Darwin. Unlike our own solar system, this virtual one has 2 suns.
It seemed utterly important to me that the foundation to create a world was to make sure that the world was acceptable to the science community.
Then we put together a team of scientists to have a look at that concept and to make sure that the laws of physics and chemistry were all represented in that model.
Typically, we search for planets through telescopes. The Darwin 4 mission simulates the next giant step, the unmanned quest to find life beyond our solar system. The ship on this mission is the Von Braun. Roughly the size of a nuclear submarine, it travels at a staggering 60,000 kilometers per second, 1/5 of the speed of light.
According to Einstein, there's an ultimate speed limit in the universe. Mother Nature is like a cop that says you cannot break the light barrier. Now, the nearest star is 4 light-years away. And Darwin, traveling at 20% the speed of light, will take 42 years to make that journey.
The metal composite nose shield that protects the ship is damaged by collisions with space debris accumulated during the long journey to Darwin 4. The planet orbits the larger of the 2 suns in its solar system. It lies just close enough for comfort in a sweet spot astronomers call the Goldilocks zone.
Not too close and not too far away, but just at the right distance that the planet can support liquid water on its surface.
The Von Braun's first priority is to call home. A laser beam will carry a digital message, but the limits of time and space make message delivery anything but speedy. Even at the speed of light, Von Braun's transmissions to Earth take 6.5 years, making it impractical for engineers to correct problems. So Von Braun and its probes will have to think on their own. The first phase of the mission is to deploy the Darwin Reconnaissance Orbiter, or DRO.
It's going to spend months monitoring weather, looking for geology, looking for signs of life.
It's going to map the entire planet, and it's going to rotate around the planet, and it's going to give us some detail on the topography.
We learned a little bit about the planet via the space-based telescopes that were around our own Earth, but now that we're actually there, we're going to look down and confirm that our guesses were correct.
So that when we put these probes down, which can only explore a small fraction of the planet, we get the most out of it.
Images surge through the DRO's camera lens. Infrared, radar, invisible light pictures reveal an equatorial mountain range and vast plains swirling with weather systems. Darwin 4 has no oceans, just a small blue sea. Von Braun's computers sift through thousands of destinations before selecting the one landing site with the most to offer. The Von Braun launches Balboa, a probe named after the famous explorer. It enters Darwin's airspace as our first ambassador to a pristine alien planet. The first contact between Earth and Darwin literally falls to pieces. The Balboa may be destroyed, but the planners of the Darwin mission have prepared for just such a scenario. The Von Braun carries 2 additional probes. Probe Leonardo da Vinci is nicknamed Leo. Leo is followed by a twin probe, the Isaac Newton, aka Ike. The probes enter the atmosphere just like the space shuttles do on Earth. The final approach is a lazy S pattern to burn off excess speed before landing. The temperature on the surface is 20 degrees centigrade. But will the planet provide a warm welcome for these new explorers? Landing on Darwin 4 after a 42-year journey, twin probes Ike and Leo need to get the lay of the land. Leo is the first to touch down and emerge from his vehicle. His bird-like head is crammed with sensors. Driven by protocols embedded in his software, Leo confirmed that Ike's landing is on track and sends a status report to the Von Braun. The news that Leo and Ike have landed is beamed to Earth. Perhaps it's fitting that scientists who were babies when the Von Braun left Earth now announce the birth of interstellar space travel.
Watching these probes from back on Earth would be much like sitting in the back of an auditorium, watching your child at a spelling bee where you know the answer and you're sitting there hoping that they're going to make the right decision and come forth with the right answer, but also knowing that you can't do a thing to help them at this moment.
Darwin 4 has a denser atmosphere than the Earth's, and the probes would have been designed to cope with that. Now, we would have known that the atmosphere was in fact denser before we got there. The way we would have known that is by looking at the spectrum of this planet and looking at the signature from oxygen in the planet. That oxygen signature would have been so broad, we would have known there was much more oxygen there in that atmosphere than we have on Earth.
Recently, some astronomers have said, bah, humbug. The conditions for life are extremely rare. For example, you need a large moon to stabilize the orbit of the Earth, or else the Earth tumbles in its orbit. You need a large Jupiter to clean out the comets and meteors of the solar system. You have to have so many Goldilocks zones. The Earth has to be just right for this, just right for that perhaps we are alone. Well, I don't think so. Because if you look at the number of stars in the heavens, perhaps 10 billion trillion stars that are within the range of our telescopes, and you realize that half of them, perhaps half of them, have solar systems around them. And if you play the odds, you come up with the realization that perhaps there are billions of planets in our universe that have conditions that are compatible with life as we know it.
Darwin Mission Day 2. Leo's first assignment is to investigate a region studded by tall, mysterious, gourd-like structures. Before he can take them on, he's got to get himself together. The process begins with systems testing. Darwin 4's atmosphere is drenched in water vapor, a free source of hydrogen, which Leo converts to inflate a large bag on his back. It's covered with photosynthetic solar panels. An algae-like material within the cells generates energy from Darwin 4's 2 suns. Leo's head contains 2 sensitive camera eyes. Its arms are simulated plastic muscle, tipped with sensors, and a versatile hand-like end for delicate operations. Thrusters on pivots push him along at a top speed of 48 kilometers per hour. Leo senses movement in his side scanning radar. But he can't investigate the source of the movement. His artificial intelligence isn't programmed for it at this point. Leo's first priority is finding his yellow-tailed brother, Ike. While physically identical, the 2 probes were created with complementary personalities. Ike is safety conscious. Leo is inquisitive and programmed to take risks. Their artificial IQs are roughly those of a 4-year-old child. Their missions can be redirected by the von Braun supercomputers at any time. Assisting them are mini probes like this spider. It's designed to explore places too tight or dangerous for Leo and Ike. The data they collect is transmitted to the von Braun for analysis. These camera discs serve as high-speed scouts. The saucers can be retrieved and recharged. Radical changes in Darwin 4's weather could tear the probes to shreds, so Ike and Leo deploy an early warning system. Small weather balloons monitor the atmosphere. It's now time for the last diagnostic check. Should Ike or Leo confront intelligent life, they'll present a calling card in the form of a hologram. Number comprehension, images of our galaxy, solar system, the Earth and the human species are offered as an interstellar handshake. Leo senses something again. Von Braun determines that Leo and Ike are fully prepared to explore the bizarre structures that surround them. Scientists will name them gourd trees. 15 stories high, they stand on a matrix of root-like stilts. Von Braun's computers determine the stilts could only support such a huge mass if the gourds were hollow or filled with some type of spongy material. But Leo and Ike are not programmed to study objects like the gourd trees. They collect samples for later investigation. Some astrobiologists predict the only alien life forms we may stumble upon are microorganisms, and the probes are designed to study them. Leo is programmed to search for them in the first puddle of water he finds. A microcosmos of single and multiple-celled life forms appears magnified 1,000 times its actual size. But Leo is about to discover that not all life on Darwin 4 is quite so approachable. This life form is the size of a Tyrannosaurus Rex, but instead of a roar, it directs a single wave of sonar at Leo and Ike. Darwin 4 has dealt the mission a wild card. In this extraterrestrial plane, the probes have met the unexpected. The mission has changed, and they will need to adapt.
The discovery that Darwin 4 is not just a planet capable of sustaining life or had life at a simple level on it, in fact had an entire complex, interactive, multicellular biosphere comparable to what we see on Earth, is one of the greatest discoveries, the greatest discovery in the history of mankind.
We can almost be certain that life that we find on another planet will have evolved along lines differently from the life on Earth.
The intelligence of Ike and Leo is very much like a small child. Intellectually, the child might know to do certain things and not to do others, but in some cases may need to be reinforced. A child doesn't know necessarily not to touch the burner of a stove, and Ike and Leo may not be aware of all the possible threats in its environment and would have to learn from those.
If we realize that there's other life at a higher order of multicellular organization, of even, adaptation to environment, I think that would rock profoundly our boat. And, in one sense, it may actually lead to a greater realization that we have to do more exploring, because our own little backyard is not as isolated and protected as we think it is. And I think it will lead to amazing opportunities. By learning about that other life, we may better recognize our own limits, our own possibilities.
The creature's eyesight may be less evolved than large life on Earth, so using sonar could be a more accurate means of locating objects around it, like Leo and Ike. Splotches of bioluminescence cover the creature's back. Scientists name this creature the arrow tongue. The arrow tongue decides the probes pose no threat and turns his attentions elsewhere.
The arrow tongue is a remarkable large predator. As far as we can tell, in terms of the land-living predators on Darwin 4, it's the largest one we got a record of.
So when we look at Darwin 4 and look at an organism like an arrow tongue, and then we look at Earth and an organism like a Tyrannosaurus Rex, we've got two different evolutionary pathways starting out with different raw materials under perhaps similar circumstances, and we end up with these two organisms that in some ways are very, very similar, and in other ways are extremely different.
We really need to examine the entire food chain on this planet, from the very smallest animals up to the largest, to get a sense of what does Earth and Darwin 4 have in common.
Leo detects nearby movement and redirects his attention. The gyrosprinter is a two-legged vegetarian about twice the size of an African antelope. The arrow tongue reveals itself as an ambush predator, capable of great bursts of speed. As predator and prey hit speeds of 65 kilometers per hour, the probes are left in the dust. Ike launches a camera disc to follow the action. The arrow tongue rapidly pursues its prey, but the more agile gyrosprinter is able to corner at enormous speed. Day 9 of the mission comes to a close. Scattered bands of bioluminescence move across Darwin 4's surface like lightning across this alien landscape. It could be a form of communication on Darwin 4. But Ike and Leo ignore the light show and push on towards their prime objective. They must scour the landing site for Balboa, the lost probe, to confirm its fate. The Darwin mission now depends on just 2 intrepid probes with the intelligence of small children. Images of the Balboa and of large life forms taken by Ike and Leo are evaluated by the von Braun. Its supercomputers now make important adjustments in the programming of the 2 probes. The probes are directed to split up. Leo will hunt for Darwin's larger creatures, while Ike explores ecosystems and plant-like life forms. As Leo's quest begins, he flies over a geothermal vent. Here he'll top up his gas bag with some hydrogen from the mist. But even during this pit stop, the probe keeps exploring. Life on Darwin 4 never stops either. In the midst of this volcanic cauldron, Leo finds microorganisms that resemble some found in hot springs on Earth. As Leo looks for big game, his twin probe, Ike, searches for plant life. Ike encounters a small, isolated forest. The floor is covered with plants. Their sticky, spherical heads are part sponge, part virus. Giant molds called Darwin tomatoes rise from the dense soil. Then Ike's sensors suddenly direct him skyward. Called trunk suckers, these creatures cling to plaque bark trees, sucking nourishment from the nutrient-rich layers just beneath the tough outer shingles. It's here that the mission reaches another milestone. After seeing life everywhere, Ike gets his first glimpse of death on Darwin 4. But death from what? Four weeks ago, Ike and Leo landed on Darwin 4 in search of life. What they found was a world of predators and prey, and an ordered relationship between the two.
The arrow tongue is a very, again, interesting organism. It has a lot of similarities to some of our dinosaurs.
It doesn't have the maneuverability of some of its prey items. A formidable high-speed predator.
It's an ambush predator. It appears to sneak up on its prey and then take them down quickly. Very high efficiency predator, very highly evolved, very interesting animal.
Gyrosprinter is a very improbable animal when we look at animals on Earth. This is an animal that needed to get away from predators, was running in a loping manner, beat things out 100 million years earlier. Its predator got faster, it got faster, until it developed this amazing sense of balance, the large feet for gripping and handling on the turf.
Looking at the shoulder girdle and the hip girdle, it appears that this animal may have evolved from a four-legged animal. It appears we have a fusion here of the forelimbs, a fusion of the hind limbs.
Truly extraordinary, something we would never predict from life on Earth.
Although Darwin 4's animal life is unlike anything on Earth, the plant life there can bear a surprising similarity to that found in our own ecosystem.
One of the things about the plants on Darwin 4 is that superficially they seem kind of bizarre. And yet when we look at plants on Earth, we find that there's a lot of really bizarre plants on Earth too. It's just that they're not common. One of the things that we might ask about a plaquebark tree is, first of all, is it transporting nutrients and water? And we're guessing that it is, but we might also ask, where does it transport them? And we didn't tell the probes to go checking, but we can learn about this from looking at the behaviors of the trunk suckers.
They're very similar to some sorts of birds, woodpeckers that we have here on Earth. They fly, they land on the trunk of the tree, they prop themselves up with their tail, and they're taking fluid from the tree. This tells us some things about the trunk suckers, where they're getting their energy, but it also is informative about the plants and what they're doing. So trunk suckers are informative about both plants and animals.
If you look at the diversity of what species look like on this planet, nature has come up with better things than our best science fiction artists and people try to conceive what a foreign species would look like. Some of these things that come out of the deep ocean just are absolutely amazing creatures. Just the diversity from the same starting materials of DNA and genes, by mixing and matching these, almost any physical appearance is possible.
For the past 3 days, the Darwin Reconnaissance Orbiter has tracked a large object moving rapidly across the surface. Now, on day 32 of the mission, Leo has been ordered to investigate what mission scientists call an object of interest. As it turns out, the object of interest is not just a single one. Leo locks on to a herd of creatures called unths. The closer Leo gets to the herd, the more his attention turns from motion to sound. Unths have nostrils and lungs, but they also inflate secondary air sacs on both sides of their bodies. Unths are named after the sound they make when they exhale through their dorsal vents. Like buffalo on Earth, the Unths are competitive, possibly fighting for dominance within the herd. Something frightens them. Leo senses movement nearby but can't locate it. His sensors are simultaneously scanning in all directions, looking for the strongest signal. The newest input is picked up by Leo's microphones. A pair of bladder horns compete. Bioluminescent antlers are displayed to scare off opponents. It may be the noise from this duel that was responsible for scaring away the Unths. Leo interprets the back and forth bellowing as a form of communication. Perhaps this alien is more intelligent than it looks. Leo deploys the Earth communication screen. Like a greetings card, it's the best form of address the visitors can offer. The bladder horn responds with what sounds like hostile noises. It decides to turn and run as Leo's sensors detect another disturbance. For the next 24 hours, the von Braun makes several attempts to communicate with Leo, but gets no reply. A grim dispatch rides a laser beam to Earth. Probe Da Vinci has gone offline. Cause unknown.
Ike and Leo's programming would be different so that they would respond differently. You have a chance of one of them responding in a situation that may not be the best response to that situation, may put the probe in danger. By having the two probes carry separate software, you have a chance to have one survive where another one might fail.
The Unths are interesting in that they occur in herds or groups. This is one of the Darwin 4 animals that we see where there is the evolution of sociality, social groups, which is also very important and evolved evidently many times on Earth.
These animals are interacting with each other in a number of sophisticated ways, probably both to establish pecking order within the herd, and even though we're not sure what's a female and what's a male in the Unths at this point, certainly the kind of interactions we're seeing with these animals are very similar to males fighting for females that we see on Earth among herding animals.
The bladderhorn is a very interesting animal for a variety of reasons. One thing that's a bit unexpected is that the bladderhorn is the only animal we've seen so far that in fact appears to use sound as a major means of communication.
It's taking some of the features we would expect to see, that is, display features that would be used in competition. We see these animals interacting front to front. Probably these horns with the bladders are fundamental in the way they interact with each other.
When we do make contact with an intelligent life form, they may be descended from predators. Take a look at our animal kingdom. we have foxes, lions, and tigers with stereo eyes to the front. And then we have rabbits and deers with eyes to the side. That's because the predators have to zero in on the prey. They have cunning, they have stealth, they know how to ambush. While if you're a rabbit, all you have to do is know how to run. So which is more intelligent, the fox or the rabbit? Well, obviously, the fox is more intelligent than the rabbit. So chances are, when we meet intelligent life forms in outer space, they're going to be descended from predators.
On his search for intelligent life, probe Leo seems to have taken a wrong turn and has still not resurfaced. It's day 77 of the mission, and unless he resumes transmitting, Leo will remain an invisible dot on a vast alien landscape. Leo's twin probe Ike soldiers on. He finds another pocket forest, the living remains of woodlands that thrived until Darwin's oceans evaporated and the climate altered. As Ike begins to scan the trees, his sensors pick up something new lurking on a high branch of a plaquebark tree. Scientists will call it the daggerist, for a reason. When Ike launches a camera disc, the daggerist is not interested in posing. The daggerist's forelimbs sink so deep, the nutrient-rich sap bleeds to the surface. Ike's not programmed to approach something this aggressive. That was Leo's job.
My first impression on the daggerist is that this is a very large praying mantis. It has a limb configuration that is reminiscent of the forelimbs of a praying mantis, although the daggerist uses them to climb trees, which was very interesting. Moving by gliding was very interesting. This is a rather large animal. The membranes involved in producing the lift for the gliding appear rather small. We have to remember that the gravity on Darwin 4 is less than Earth, and we also have to remember we're gliding through a thicker atmosphere, so the dynamics are going to be different.
The study of plant life is Ike's mission until von Braun orders otherwise. Finding water is statistically the most efficient method of finding vegetation. Ike scans a carpet of moss at the edge of a deep water marsh. But what lies beyond is even more intriguing. Ike surveys 3 odd mounds covered with saplings, but appearances are deceiving on Darwin 4. Rising 5 stories into the air is a massive paradox. The Groveback. Grovebacks bury themselves alive for long periods of time. They're not hibernating. They're feeding. Absorbing nutrients from the soil through the skin of their underbodies. When the ground is depleted, they move on in search of new feeding areas. Groves of trees sprout from these immense creatures. The groveback provides them water from its spongy tissue. The trees inject sugars into the groveback, enough to enable these colossal animals to make their next move. A burst of data stimulates von Braun's computers into action. Ike's brother, Leo, has come back online.
If Ike or Leo were to come back after having gone offline, the first thing you'd want to know is why. They'd need to send you some information, what caused the reboot, anything they could tell you, as well as, if possible, have saved some data from just before the problem so that you'd be able to see what was going on when the problem occurred, and then their response to it so that you could start trying to figure out what had happened.
The groveback is the most massive animal that we have a record of on Darwin IV. Its tremendous size supports my own theory that I've put together on these animals, and I think shared by some other scientists. They have a much lower body density. The size of our groveback far exceeds the mass of any of our dinosaurs that we have records of living on Earth.
People ask me all the time, why should we care about discovering new things if it isn't applicable to us? If it doesn't put food on the table or gas in the car, why should we care? And all I can say is that, if you're not curious enough to want to know the answer to anything we can discover, then you're not human.
The animal life on Darwin IV has proved formidable. But what challenges will the weather hold for Ike as he soldiers on without his brother? Now, on day 91 of the mission, the von Braun tries to locate Leo, who has gone astray, while his twin, Ike, moves deep into the foothills of Darwin IV. Like groves of pine on Earth, the pocket forests of Darwin IV are covered with colonies of passive organisms that feed on the moist, spongy floor. As Ike continues to explore, the Darwin Reconnaissance Orbiter detects a sudden atmospheric disturbance, increasing winds. While Ike's sensors measure the wind at only 50 kilometers per hour, the super-dense atmosphere gives it the kinetic punch of a young hurricane. Ike has no choice but to head upwards to get out of the storm. Ike fires a salvo of weather balloons to sample the currents of the unexplored upper atmosphere. Unlike on Earth, where storms are fed by great oceans, Darwin IV's airspace is a shifting maze of thermals rising from hotspots created by the two suns. The power of passing storms presents a new and potentially lethal threat to the mission. Ike is little more than a fragile sack of hydrogen on a planet where even the weather seems predatory. But for now, it's back to the business of discovery. Ike's motion sensors pick up activity within the grove. Not in the ground, but in the air. The link between a deadly hunter, its prey, and the plaquebark trees suddenly unfolds. The daggerist fills in the missing pieces of a predatory puzzle. The trunk sucker feeds on sap from gashes made by climbing daggerists. IX data confirms that daggerists extract the pre-digested material from the corpses of their prey. A gruesome but energy-efficient survival strategy on Darwin 4.
I think statistics would say life is a cosmic imperative. I personally believe, from all the observations that NASA has offered humanity for the last 50 years, suggests that the environments could be there. We now recognize potential habitats on Mars today that you could insert Earth life into and have it potentially be sustained. This is amazing. 25 years ago, we might not have said that. And then the question is, why don't we see it all around us? And I think that begs the bigger question, do we really know what we see all around us? We are just taking those baby steps into that cosmic ocean with a few elegant robots and a few human voyages. We've barely left the cradle.
As Ike and Leo begin their 4th month on Darwin 4, the mysteries of this alien planet continue to unfold. Flying scavengers take on a larger-than-life walkabout. Aerial predators hunt with fearsome precision. A tranquil sea contains more than meets the eye. And what has happened to Leo?